So now we'll go through this combustion analysis problem together. If we have a 2.04 gram sample that contains carbon, hydrogen, and oxygen that undergoes a combustion analysis, we find that 4.48 grams of carbon dioxide and 2.4 grams of water are produced. Find the empirical formula. So first we're going to find the mass of carbon and hydrogen, because remember oxygen is present in both of them, so we can't find it directly. So we're going to take the 4.48 grams of carbon dioxide, that should be CO2. I made a lot of typos in this, I apologize for that. But this should be CO2. CO2. Okay, they didn't give us 4.48 grams of carbon, they gave us 4.48 grams of CO2. Okay, so make that correction. Then we're going to find how many moles of CO2 that is by dividing by the molar mass of carbon dioxide, which is the molar mass of 1 carbon plus the molar mass of 2 oxygen. Then we're going to find the molar ratio between carbon and carbon dioxide. So there's 1 mole of carbon for every 1 mole of CO2, and we can tell that by the subscripts. Then we're going to go back from moles to grams, moles of carbon to grams of carbon, by multiplying by the molar mass of carbon, which is 12.01 grams per 1 mole, and we find that we have 1.2 grams of carbon. We're going to do the same thing for hydrogen and water, so take a second, pause the video, see if you can find the grams of hydrogen. When you do that, you should find that you get 0.24 grams of hydrogen. So we take our 2.4 grams of H2O, convert to moles of H2O. There are 2 moles of hydrogen for every 1 mole of H2O, and then we go back to grams by multiplying by 1.01 grams per mole, and we get 0.27 grams of hydrogen. For step 2, we want to find the mass of oxygen. So we found the mass of carbon and hydrogen. Everything remaining in that 2.04 grams should be oxygen. So we're going to take the total mass, 2.04, minus the mass of carbon, minus the mass of hydrogen, and we find that the mass of oxygen is 0.55 grams of oxygen. Now with this, they didn't give us the percent of carbon, hydrogen, and oxygen. We found the grams. So we don't assume a 100 gram sample in this case. We're just going to go straight from grams to moles. So that's the difference between the other problems that we did where they gave us the percent composition. So we're going to convert all these grams to moles. So carbon, we have 1.22 grams divided by the molar mass, and we get 0.102 moles. Go ahead, pause the video, do the same thing for hydrogen and oxygen. When you do that, you should get 0.27 moles of hydrogen and 0.034 moles of oxygen. For step 4, we're kind of back into that empirical formula rhyme. The next step is to divide by small. So we have the number of moles of each of these, the smallest of which is oxygen. So we're going to divide every one of these numbers by 0.034 moles. When we do that, we get 3, 7.9, and 1. The 7.9, typically if the values that you get for this divide by small division are less than 0.1 away from a whole number, you're good to round. So 7.9 is good to round. If you get something else, like if you were to get, say, 1.33, that's not close enough to round down to 1 or up to 2, so you would actually have to multiply everything by 3 in order to get whole numbers. So if you don't get a whole number here, that's when we would multiply till whole. So those multiplication factors, for like 0.33, it would be multiply by 3. For 0.25, you would multiply by 4. And for 0.5, you would multiply by 2. So those are the most common ones that you'll see. Typically, you can just play around with it until you get a whole number. So the empirical formula of this compound is C3H8O. Okay, now we cannot find the molecular formula from the data given here. To find the molecular formula, they would have had to given us have had to give us? Whatever. We would need the molar mass of the compound, which would have to be given to us. And in that case, we would divide the molar mass of the compound, divide by the empirical formula mass to find the multiplier and apply it there. So you can find the molecular formula, but only if they give you that tidbit of information that you need, okay? So that is it for our 1.3 to 1.4 notes. Just let me know if you have any questions.